Hello students, I am Dr. Ritapa Bhattacharjee, Physics Department, Assistant Professor, Basic Science and Humanities, Swami Vivekananda Institute of Science and Technology. Today, we are going to solve a problem from electromagnetic theory which came in the year 2022-23 odd semester of MAKAUT. So this question is two parts are there. So each part they are giving 2 marks, but a lot of understanding is needed to solve it. So what they say, the question is an electric wave is given by Ex equal to cos 1000x minus 5000 t. Find the wavelength and speed of propagation. So this is the first part of your problem, where they asked to calculate the wavelength and speed of propagation. In the second part, they asked, show that the displacement current is negligible compared to conduction current at any frequency when the conductor is subjected to an alternating field. So you have to show the displacement current is negligible compared to conduction current. Means conduction current is very high and displacement current is very low. That you have to show. And electric field is given this way. You have to use this only for showing that. So let us solve the first part, then we will go for the second part. So in the first part, given the electric field Ex is equal to, let us just see it once, cos 1000x minus 5000 t. Cos 1000x minus 5000 t. Okay. So this is your given electric field. That is, this is a component of X. Electric field's X component they have given, only the magnitude they have given. Okay. So if we comparing with standard X component of an electric field as, so how it should be? It should be Ex equal to, so if I consider that A is the amplitude, which is 1 here, cos omega t minus k. Sorry, it should be, one second, it should cos kx minus omega t. So this is the form. So what we are going to do, we are going to compare this one with the given equation. So I already written here. So here A is your the electromagnetic waves amplitude, K is wave number, omega is angular frequency. So if I compare here, you can see the two things. So what I will do is, you see here, there is no value given here, so I can consider it as 1. Okay, so amplitude is equal to 1. Okay, in the cos part, if I compare this inside the components of the cos part, so you see here the with x, this is your wave number k, and with x here is 1000. So we can consider the wave number k is equal to 1000 and omega, that is the angular frequency, which is along with t it is there as a component. So here the component is 5000 t. So we can say omega is equal to 5000. So if this is the case, then we can say, comparing the two equations, we can write omega is equal to 5000 and k is 1000. Now, in the question they asked us, let us see again. In the question they asked us what is the wavelength and speed of propagation. So we have to find a way to connect the wavelength either with omega or with k. So wavelength, say lambda, is equal to twice pi by k. Okay. So twice pi by k is your wavelength. So if this is the wavelength, then we can calculate it from here. 2 into, for pi we can consider it 3.141. Okay. And for k, let us write 1000. So it will be in SI unit. So if I do this calculation, I will be needing a calculator. So definitely you also use your calculator to calculate. So it will be your 2 into 3.141 divided by 1000 is equal to 0.006283 SI unit you can utilize. Okay, so this will be your meter. This is your wavelength. Okay, a little I can modify here 6.283 into 10 to the power minus 3, like that way you can write. Otherwise if you keep it here also, no problem. So or you can say like that, 628.3 into 10 to the power 1, 2, 3, 4, 5, 10 to the power minus 5, like that. Okay, so this is my wavelength I got. Now I will calculate velocity or speed of propagation. Velocity or let us see what they asked us. They asked us speed of propagation. So let us write the word or speed of propagation. We will write with the symbol V. V is equal to omega by k. So this value omega by k. So this value what I will do is omega by k I will write here and my omega is 5000 and k is 1000. So very simple answer is equal to 5 meter per second. So this is my speed of propagation. So I got my first part of the problem done. Very simple thing, just need a little bit of understanding. So let us see what was the next part. The next part is telling, show that the displacement current is negligible compared to the conduction current at. So this I have to show. For that, we know we are writing just the formula for the displacement current density and conduction current density. Displacement current density JD, its vector quantity is equal to epsilon del E vector del T, and conduction current density say JC vector is equal to sigma E vector. Okay, so this is my two equations. What we will do is, this E vector we will consider the given x component of the electric field. So for that, so if we are considering the x component of this vector quantities, and we will consider only the components and we will not consider the vector, unit vector or the direction of it as of now, magnitude only considering. So with that we have what we will do is, we will write first here is equal to epsilon del T. Here you just write, we have to write the value here, 1000x cos of 1000x minus 5000t, cos of 1000x minus 5000t. So this we will write here, and here what we will write, sigma cos 1000x minus 5000t. So I will just little bit, I will do the differentiation. Cos of x here will be minus sin x, and then because it is already having a minus, so both minus will become plus. So here the differentiation value will be, if I take derivative with respect, partial derivative with respect to t, here is a minus. So this will be, epsilon will remain as it is, and 5000 will come here, 5000 sin 1000 x minus 5000 t. So this is my value here. So you got the value of epsilon 5000 sin of 1000x minus 5000 t, and here sigma will, here it is as it is, I do not need to do anything, no derivative. So instead of what I will do here is, we will give some number here. So this is 1 and this is 2. So what we will do is dividing 1 with 2 equation, we get, just write here, JD vector by JC vector is equal to epsilon 5000 sine of here 1000. So 1000x minus 5000t, and then divide sigma cos 1000x minus 5000t. So I have written here this format. It will go upward. So after I do here, it's a very simple thing. JD vector by JC vector. So epsilon will remain here, and here it will be 5000 as it is, and here I can write 10 sin by cos 1000 x minus 5000t. Although it is not needed, we are going to use a logic here, divided by sigma. Okay, so let it be whatever, there is nothing to worry about. We got this condition. Now here we will use some logic. What is the logic? We will use, like, if you have a good conductor, in that case, so we will write down the logic for a good conductor. One second. I have to see the question once. So they asked us show that the displacement current is negligible. So I have to show my displacement current density is negligible. So for that, for a good conductor, epsilon is much greater than sigma into omega. So or I can write one second. I have to write okay, I have to correct here. For a one symbol I have written here. So be careful about that. So for a good conductor, sigma is much greater than epsilon. So for a good conductor, sigma is much greater than epsilon omega. So in that case, epsilon omega is by sigma. So this will be much less than 1. So if this is the case, I can say like that. So JD vector by JC vector is much less than 1. So here I will get my conclusion that my displacement current is negligible compared to conduction current. So this logic is very important here. So this sigma is much greater than epsilon omega. This means epsilon omega by sigma is much less than 1. So if this is the case, so or now you see here, if you just drop this omega, you just see epsilon by sigma. and JD by JC. Here also omega is there, but which is inside the triangle relationship. But we can write here JD vector by JC vector is much less than 1, or JD vector is much less than JC vector. So this is fully your logic application to solve this equation. Hence, the displacement current let us see, we will take this sentence from here. Displacement current is negligible compared to conduction current. So if their current density is like that, so current also we are expressing in this format. Hence, the displacement current is negligible compared to conduction. Okay, so this is my second part of the answer. So let us just have a quick recapitulation what we have done here and the important things that we need to learn from this type of problems. So they gave us an electric field. This electric field they have given us, and they gave us two questions. Calculate the wavelength and speed of propagation first. So what we have done here, first we have compared this equation with the standard electric field x component, and we wrote all the terms associated. After that, we have considered the value of angular frequency 5000 and value of the wave number is 1000 k. So we used two important relation. One is 2 pi by k equal to lambda, and we calculated the value. At velocity or speed of propagation, we calculated v equal to omega by k. Okay. So here we also I will write, hence the wavelength of propagation is always it is better to write a concluding statement after finishing the all problem. Wavelength of propagation is 628.3 into 10 to the power minus 5 meter, and speed of propagation is 5 meter per second. Okay, so this is my first part. The second part, so remember the two formulas here. Lambda is equal to 2 pi by k and v equal to omega by k. So these are the two important formula that we need to remember from this problem, which may come in other problems also. And again, here it's a logic. So fully logic. What we have done here, we have written here the displacement current density, epsilon, del E del T, and JC, conduction current density, is equal to sigma E. We have taken the electric field as they have given us. Then we took the ratio of displacement current density with the conduction current density, and we use a logic. What is the logic? Sigma is much greater than epsilon omega for a good conductor. So we used, if this is much greater than epsilon omega, then the ratio is much less than 1. So this ratio is also much less than 1, and like that, so JD is much less than JC. So like that way, hence displacement current is negligible compared to conduction current. First part gave us two formulas, and the second part gave us a logic to learn and remember. So this is the whole problem for whole solution of this problem. So please note that this is also an important thing to remember here for a good conductor. Only if it is a good conductor. If it is a bad conductor, it won't. Okay? So this is the answer. Thank you.